Next, we have a talk about next-gen reasoning models with Nathan from AI2 and Interconnects AI.
So I'm Nathan. I'm a research scientist at the Allen Institute for AI, and I also write a blog, Interconnects AI, that is on Substack right now. And I spend my time thinking about where language models are going and try to build them in the open so that a lot of businesses, scientists, and everyone can kind of use that to build a more open AI ecosystem. And especially looking back at 2025, you can kind of see that everybody has a reasoning model now. We've gone through this stage of everybody figuring out how to do this, mostly. Some labs don't have them yet, but that's kind of the direction that it's going. And there's some foundational things like this OpenAI blog post that everybody has shown you a lot of times, where the left is that you do more reinforcement learning training and the performance goes up. And that also enables this inference time scaling thing where the models can use more tokens to answer a prompt and the scores get better. And it's like on this list with AI2, we'll add ours, which is like I'm one of the people that led the paper that coined this term RLVR, reinforcement learning with verifiable rewards, that you may have heard. And it's like we're at AI2 working to join this list of reasoning models. But that's not mostly what this talk is about. Most of the talk is like, what are we actually going to get out of reasoning models beyond just these high benchmark scores that start to not make sense in these frontier model releases, and like what are the next frontiers of training them in order to push these boundaries to new things that we want to do. So one of the things that is obvious to me when using these is that reasoning is starting to unlock just more ways to use AI. So this is an example that I'd like to share, which is in my workflow, like trying to reference a niche academic thing, which is finding a GIF of over-optimization and reinforcement learning. It's something that I need to look up every few years for talks when people think about this again. And I've asked O3 to do it, and it gave me like a direct download link when I sometimes struggle to find this on my own, which is just like a very useful thing to do for my career. And here's the GIF that many of you may have seen. It comes back into these AI circles since I think it was first released in 2016 as a popular thing of showing that these reinforcement learning agents can go wrong. And the search here is just a new ability that everybody's learning what this means for how they use AI, and there will be plenty of more things like this. So there's more examples that are probably more interesting than just this search, which is these whole new application touch points that are coming because we have these reasoning models. The first one that we got was deep research from OpenAI, which is just much better at synthesizing and getting the right information to anything from a simple to a complex query. I like to use it for a lot of kind of unintended uses that I say, so you can really restrict where it looks. So you can restrict it to just look at your website and find all the blog posts on your things and find through lines and stuff like this, or really local information, like what's going on in Seattle today, why is there traffic? And deep research will still spend a lot of time on it and compute, which is really beneficial. And then some of the frontiers that we're watching in software engineering from like these interactive coding agents. We saw Gemini launch theirs today, where it's in the terminal and you're giving feedback in real time. I use it to build some small websites, such as the book that I wrote on reinforcement learning from human feedback, and just spinning up projects is really easy with these. And the direction we're seeing the reasoning models going is like these independent agents, where independent coding agents kind of end-to-end, where you give it a prompt and then it opens a PR for you, are things that exist, but they're not as useful for everybody yet. It's just kind of good to think about where new product touchpoints are going to come. And a plot that was going around, especially in AI training circles a few weeks or months ago, is this plot from Meter, which is, I think, a nonprofit or an institution in Berkeley or nearby, which was looking at the types of tasks that new AI models can solve. So this is date on the x-axis, and the y-axis is looking at how long it takes a human to solve a certain task. And we're seeing that language models are climbing this chart in the solving tasks that take humans increasing amounts of time, even on a log scale. And the thing that I think about when training these models is that it's not just like we write a bigger config and we use more parameters and the model just solves these things. The progress being made in the industry is like people really pushing on this to think about what the research vision should be and like what we want to train the models to do. And this is the frontier that people are looking at in the labs when everybody talks about planning and these agents is like what training techniques and ideas do we need to push out this frontier? And the first reasoning models with this O1 release and that plot that I showed were kind of this first surge where we have these models here after 2024 where they're starting to reach this like 15-minute stage. And the next stage is really what people in these frontier labs that I think about is like, what am I going to do in 2026 to make a model that I can release, but it really can do these complicated tasks? So that's like the core question that is what I'm talking about in this talk is like, what are the things that we think about when we're trying to make these next generation models? And hopefully that's useful as a path to see where these AI models are going and what you should be building and expecting that people are going to drop the model on your lap and be like, what are you going to do with this? So I've been coming up with a set of traits that these models need. And everybody talks about planning, but it's good to see like what we got from reasoning models and how that builds into things that we will want in the future. So the first thing is skills, and I've alluded to this, but effectively once we turned this reasoning model thing on, we've gotten crazy improvements in benchmark scores. And those types of skills are just things that the model now has and can use them to solve a lot of different tasks. And then a lot of these future ones are kind of things that we want to have, and they're well motivated, but we might not know how to do them. So another thing is calibration. I think if you look either at the research or using these models, you'll see that plenty of the new models, you ask them a question, and then it'll think for a couple minutes, even if the question is like, what day of the week is it? And it'll spend 10,000 tokens in the background, and then that's spending real money on the infrastructure side, but also time on the user side that isn't sticky. So we want the models to kind of know how hard they need to think on certain problems. And that's something that OpenAI is hinting at for GPT-5 when they have this illusion of a new model interface, which they won't tell us exactly what it is. And the last two on my list are really related to this idea of planning and making agents that everybody's talking about now of like we're going to have these language model agents, but what does it mean that what is the underlying model doing differently to make agents a reality? So one of them is just strategy. I think the best motivating example I have for this is not really the problems that people are using language models for now, which is like edit a code base. But if you were to tell a language model that you have a very specific business problem or need for very specific software, like how can it come up with a plan to do that end to end? And what is the really narrow strategy or to solve a specific research problem where it has to finagle a really narrow path to get to the right answer and not just kind of a general like, oh, I'll try this approach again. And then to navigate the plan that it writes, it needs to be able to break down problems independently. We're used to using language models where we ask for one piece of information or something, but in the future, what the models will do is that you can ask it however hard of a question that you want, and it can use the tools to break down the question on its own or dispatch other agents in the background. And we need models to we need to train the models to do this. It's not just going to be something that comes out of prompting alone. So I'm going to kind of go through these again in more detail for each of them. But it's like we have good skills. There's a bunch of research underway on calibration, but I think it's actually more of like an industrial problem that people should be talking about. And then planning is what everybody is talking about with agents. And this is kind of scratching the surface of what a agentic language model will mean. I've mentioned this term. It's good to throw up this slide for people. Some people have had background in reinforcement learning in an AI class, and this is kind of redrawing a classic diagram in reinforcement learning for what people are doing with language models when they're training it on something like math. So for a math problem here, the training data will be some sort of question here as the state. The language model will generate a completion to this, and then there's normally some Python function that looks at the completion from the language model and says, was that answer correct? And then the training regime at a high level as simple as you reward the agent for getting it right versus wrong. And there's more complexities and so on, but it's really grounded in very basic ideas of reinforcement learning, kind of modified to fit what people are doing with language models. And what this has given us, if I talk about skills and say we have big jumps, well, if you take some popular evaluations such as Humanities Last Exam, AMY, GPQA. These are a mix of math and information processing and knowledge tasks. If we look at where OpenAI or a leading model was before o1 was released with GPT-4o, one of the latest ones, these are the types of scores. And then when you switch to an o1 type model, you get these huge jumps, and then you can click follow with o3. And this is the direction that we're going to keep seeing, is just that there's certain tasks like extremely hard math or kind of this very hard scientific reasoning that the models were either iffy at or couldn't do before. And these kind of gains enable you to just try a lot of different things with the models. And another important thing to this is that the list is going to be added to. So like these evaluations that you see from the labs don't capture all of the information. And we can kind of expect the models to keep acquiring new skills as they become useful, especially if there's new product touch points that people want to enable. And then on the other side of skills, what happens when you're focusing on this sort of reinforced learning training is that it becomes so correlated between performance and having a very high sequence length that the models generate. So the models just learn to generate a lot of tokens in the output. In apps like ChatGPT, we don't see all of these because they're hidden to the user, but we still feel the latency where O3 is taking minutes to complete a request and doing stuff in the background. And we want to have these models not always do that. And the approach is generally that getting to these skills is so valuable that later down the line, you're going to go and fix this calibration problem. But that means that now it's becoming more of a thing where it's, if performance starts to saturate, let's make the models actually exactly as useful as the users need. So there's a bunch of research on this. They show things like models generating hundreds of tokens when asked to do simple addition, or kind of comparing. On the right is the difference in blue versus yellow is when Quen switched from a traditional post-training stack to reasoning. It's like all the answers just get 10 times as long. And that really pushes the infrastructure side in many different ways that I'm not an expert on. I just kind of feel the pain of it when trying to train these models, that everything's a lot harder, either on the research side or just serving it to users. And then I think where this really gets interesting is, again, is on these two things that I loop into planning. A good thing to do is just playing with these models and making this talk. What I do is I look at DeepSeek, because DeepSeek is a frontier reasoning model, but you can see the chains of thought and just see what is going into the models, like processing the problem. And if you ask DeepSeek what is considered one of the hardest math evaluation questions, so it's frontier math, one of the example problems, it doesn't do any planning. What it does is it's just like, okay, I'm going to start the problem, and then it generates 60,000 tokens, which is like 45,000 words trying to break down this math problem. And if you think about what you do when you're given a hard problem, it's like you're going to have to break it down in some way. A simple way, a cop-out might just be that you ask the model to generate a plan, and these are smart models, and they can do it. But as we get to these more complicated problems where you're trying to have autonomous research and these really new frontiers of knowledge, the models need to have a sense of where do I go and what is going to be a dead end. And with this is kind of like, once the model is starting to plan on its own, I think this is the one that is a must-have, which is that the models need to be able to break down the subtasks on their own. I think if you play with Claude Code or Codex or one of these code agents on their own, it's very variable on the sorts of tasks that you can give it if it will actually solve it. And the people who get the most benefit out of AI right now just know kind of what the models can solve and what they can't. And you're doing that work for the model, and across a complicated task, you're always kind of dolling out what the next thing it should do is. But there's a whole bunch of questions, which is like, how does the model manage its internal memory? How does it avoid revisiting things that it's already failed on? How does it avoid re-asking the user for feedback? And these are, you can frame some of these as tools that the model could call. The model could call in a more powerful model or parallelization. But these are not things that happen for free. If you go back to this DeepSeek example, there's a bunch of really simple tools that models can use now, like translating their reasoning into code, which they can execute to get very precise answers. But the complexity here is going up a lot if we're trying to give them, say, build a whole website at once with some sort of data backend. I think that those are things that the models are going to be able to do soon, but they need to be able to manage the complexity, if not simply because we know that the code bases don't fit in the context windows of the models anyways. There's just a lot of little things that we need to build to make the models do this automatically. This is where I started to transition into like what training actually means. So I talk about like we don't get these gains for free. And an example is all the media and how long Q-star was being talked about. And the Q-star era of OpenAI was when they were doing the hard work to generate these initial reasoning trains so that the reasoning model O1 could exist. And a lot of the hype from the media was that people were seeing these initial works that OpenAI was doing. And the data points they were training on were just these really interesting novel creations from the language model, but this took a very long time. And the labs are or need to do this sort of work for planning in order to make these really long sequence tasks work. Thankfully, with these reasoning models that are so skilled and just capable of a lot of things, I don't see this as hard of a task as kind of pushing Q-star across the line. But these labs really look at these things of like, what do we need the models to do? How do we get the data to train them on that? And on the right is kind of an example of a basic idea of like the models can just plan before they dive into thinking. The example of these XML strings is kind of like what is in the back end of what the model is actually doing, these special tokens to kind of abstract what it is doing at different times when answering a prompt. So to kind of tie this home, I started with this example about search, which is that the model O3 is extremely skilled at search, and it can find these really niche pieces of information. But at the same time, if you're a heavy user of deep research or a similar agent, you'll kind of see that like half the time the model does exactly what you want, and half the time it just doesn't do it at all, even if your prompt is very similar. So I attribute this to the model is really highly skilled, but it doesn't really have the guidance to put this together for a couple minutes of work independently to really always be reliable at breaking down a task into multiple steps. You could also think about like O3 is really bad at doing like shopping comparisons because it just can't ingest all that information and process it in order. It'll just kind of return some of the first results it finds eventually, and I can't be quite as confident in that type of behavior. So this is the taxonomy that I proposed, and then I'm going to kind of wrap up here, here soon. But this taxonomy will be expanded. I think things like context memory don't necessarily fit into this, but just knowing what's next with the reasoning models should provide a lot of value because this will come sooner than you think it will. I think like they're going to keep climbing O3 and O4 and all of these things, but the models are going to start to do different things, and the communication around it might not be as clear because the benchmarks are a little bit messier, where it's not like a self-contained math problem. It'll be a whole code base. So that's why it's like, my question is like, what is this going to feel like? And I think that agent progress is going to be a lot higher variance than models. For the last 2 years, we've been seeing these plots where they're like, we have these benchmarks, the models get more of the questions right, we're moving on to harder math questions. But that kind of stops delivering value to people because the questions have just become out of scope. And the bottleneck was that these language models are being tested in one call, but now with agents, it's kind of like we had these things. And with agents, it's very different, where if you use one of these, they're doing tens or hundreds of thousands of calls in the background. And you really need to get more of like 99.9% of those smaller things right, rather than having this mythical answer to one really hard question. So that's why it's like one little generation could one little mistake on data formatting could throw the agent totally off of where it needs to go. And I think that we're going to see the industry kind of mature and change, and how you're getting these, like Gemini 3's announcement is going to be much more about this like Gemini code and all these agents and saying how they're more effective rather than just that, oh, this is their new best model alone. So we're going to kind of see this type of thing where randomly OpenAI is going to release a new product. The Codex agent was the most recent thing, which is kind of a mix of skills from the model and then robustness. But most of it is going to be that these Claude Code-like things can just get better so fast, because it might not actually be the underlying model being necessarily unintelligent, but just some stupid thing that the model couldn't do in data processing or compressing its context. So I'm really excited about this because these tools are useful, but it's a little unsettling because we're going to have to get used to new industry norms on how model releases and so on works. And this is kind of my last selling point, is that when we're measuring progress on these models, we really need to do our own evaluations. So it's like agents are doing these really hard tasks that are kind of hard to break down and measure, but when we're going to actually finish up, is like we really need to be doing our own evaluations internally. I'll just put this on the screen. The point is that it's hard to trust what the agent numbers are because it's all about our specific use cases. And the agent paradigm, where it's less about the single model, makes it even more pressure on the user to build their own evals because the pace of progress will be different. So thanks for listening. I'm happy to discuss this more and where I see the models going. And thanks again.